All right, we're going to be reviewing perfect square trinomials. And just a review of a perfect square is a number like 4, right? 4 is a perfect square of 2, and a number like maybe 16, which is a perfect square of 4. So when it comes to trinomials, that means there's 3 terms. Those 3 terms, which you should know, ax squared plus bx plus c. That is a perfect or well-known trinomial. So we're going to actually be working with that to be able to find a perfect square. And an example of a perfect square, say I have x plus 2 squared. Well, I know that that little 2 means that there's actually 2 of them. So I'm just going to say x plus 2 times x plus 2. All right, but now when we FOIL, remember I have my first terms times my outside terms, then my inside terms, and then my last. So x times x is x squared, 2 times x is 2x, and then another 2 times x is 2x, and then I have lastly a 4. So then simplified, I get x squared plus 4x plus 4. And that is a perfect square trinomial. Okay, this is a perfect square trinomial. All right. Well, if I were to say, if I didn't know what that c factor was, this guy, it's actually b over 2 squared. Okay, that is the value. And if I wanted to check that, well, my b value is 4. So I have 4 over 2 squared. 4 divided by 2 is 2. And then 2 squared actually equals 4. So it does end up equaling your last value, which is c. So we're going to actually be using this as our way to find missing components of our trinomial. So if we're looking at this, I know my value of 5 is b. So I'm going to do 5 over 2 because it's b over 2 squared. Well, that square goes to both. So 5 squared is 25 and 2 squared is 4. And I can't reduce that anymore, so my answer is 25 over 4. Just if I were able to, let's say, go to number 2. All right? Well, it's b, okay? It's b over 2. So I have 7/4 all over 2. Okay, well, I know my flip, skip, and multiply. So if I make this 2 over 1, I skip the first, I flip the second, so 1 over 2, and I multiply them both. And so it becomes, oops, forgot my square. It becomes 7 over 4 times 1/2 squared. Reduce that to 7 over 4 times 2 is 8 squared. And now I can square my top and my bottom. So 7 squared is 49, and then 8 squared is 64. All right, so that would be my answer. You'd have 49 over 64. Now let's move on to, say, number 3. Okay, my b value is 7, so I would have 7 over 2 squared. Well, that's 49 over 4. That would be my answer. It's just 49 over 4. All right, what about moving to number 3? Number 3, okay, don't forget, so all these have been positive so far, but now I have a negative. All right, I have a negative right here, so I'm going to have 1 over 4, negative 1/4, over 2 squared, and again, flip, skip, and multiply. So I'm going to skip the first one, which is negative 1/4, flip the second one, and then multiply. So my flipping of the second one would be 1/2. Negative 1 times 1 is negative 1. 2 times 4 is 8, and that is square. And when I square both of that, 2 negatives are going to make a positive, and 8 squared is 64. So it'd be 1/64. All right, so let's just say if I move down to number 5, all right, number 5, identify my b. My b is negative 5. So plug it in to b over 2 squared. So b over 2 squared, I have negative 5 over 2 squared. And negative 5 squared is going to be 25, and 2 squared is going to be 4. And that's the most I can reduce it. I can't go any more, and I can't go any less. So I want you guys to try on your own number 6. I'll be checking for this, in class to see if you tried number 6 by. All right, so when we're solving by completing the square, didn't want that. When we're solving by completing the square for a trinomial, we actually just want our x variables on one side and our numbers without an x on the other. So I'm going to add 14x to each side. So then I'm going to have x squared plus 14x equals negative 24. Now, how I figure out, my missing equation is I know that that is b, so if I want to solve for that missing side, I need to know what c needs to be. So b is 14 over 2 squared, right? I should have, if you look in here, I'm really looking for a blank space plus something, right, equals negative 24. I'm trying to complete the square. So I'm going to figure out what my last thing is which is going to be 7 squared, and that equals 49. So I know this has to be a 49 in here. Well, if I'm adding a 49 to one side, I have to add it to the other side. So no matter what, I want to complete the square because now I know this is going to be x, right, plus 7 squared equals negative 24 plus 49 is going to be 25, right? So I know that because of my perfect squares, if I were to multiply x plus 7 out times x plus 7, I end up getting this whole thing. So I then just combined them to x plus 7 squared. Now I want to get x alone. So I'm going to square root each side, which means I'm going to get a plus and minus. So I have x plus 7 equals plus or minus 5. Well, if I subtract 7 from each side to get x alone, I get x equals negative 7 plus or minus 5. You're not really done because this can be simplified. So again, it can be split in two equations. You have negative 7 plus 5, and you have negative 7 minus 5. Negative 7 plus 5 is a 2, negative, and then negative 7 minus 5 is actually negative 12. So your final answer would be x equals negative 2 comma negative 12. And we're going to do another example of that. Again, I'm just completing the square. So, congrats, great. I have my x's on one side and my numbers on the other. Well, now what I just need to do is I need to complete the square. I know that this is my b, and to get my last thing, so I'm going to have x squared plus 14x plus blank. Okay, that's important. You need that plus blank equals 74. I know from my last problem, it's going to be 14 over 2 squared, which ends up equaling 7 squared, which equals 49. So I'm adding 49 to each side. So I'm adding, didn't want that, do my eraser, I'm adding 49 to each side. I know that this is a perfect square of x plus 7 squared, okay? But 74 plus 49 is 123. If I want to get x alone, I'm going to have to square root, which means I get x plus 7 equals plus or minus square root of 123. This cannot be broken down into any more parts. You can leave it like that. Well, then I'm going to get x minus 7, right? I just want to subtract 7, get these to cancel out. And I'm going to have x equals plus or minus, or you know what would be easier? I'm going to put negative 7. So x equals negative 7 plus or minus square root of 123. If you end up doing plus or minus 123, whoa, let's make that nicer too. 123 minus 7, that's fine too. They're the same thing. I just think this way looks a little bit neater. All right, so that's how you would complete the square according to a trinomial. And if you're looking at, say, number 5, where we have 6x squared plus 12x minus 20 equals negative 2, well, again, I want to get all my numbers on one side and all of my variables on another. So I'm actually going to add 20 to each side. Okay, I'm going to add 20 to each side. So I have 6x squared plus 12x equals negative 2 plus 20, 18. Here's something crazy though. Between 6, 12, and 18, there's a common factor of 6. So I'm going to divide everything by 6, which then you get x squared plus 2x equals 3. All right, well now, to find out my addition, I'm going to have my b equals what value? 2. So I'm going to see what b over 2 squared, b is 2. So 2 over 2 squared, well, 2 over 2 equals 1, 1 squared equals 1, so I'm actually just adding 1 to each side. That being said, I get x squared plus 2x plus 1 equals 4. Well, this I know is a perfect square. That is a perfect square of x plus, not x plus 2, x plus 1 squared equals 4. Now I want to get x alone. So I square root, and I end up getting, bring it up here, I end up getting x plus 1 equals plus or minus 2. And then I subtract 1 from each side. I get x equals negative 1 plus or minus 2. And after you solve them into their two equations, you're going to get x equals 1 or negative 3. Because you're going to have negative 1 plus 2, and then you're going to have negative 1 minus 2. So those should be your two answers.